Hi everyone, we're starting lesson number 18, and we're looking at section 3G on further expansion. Now before we do the expansion, the further expansion, I just want to go very quickly over all the different forms of expansion that we have already looked at. So very quickly, if we are multiplying a monomial by a binomial, so that would be the first case we have here, a times bracket b plus c, then we would be using the distributive property, so we would have a times b plus a times c. So giving an example, negative 2 times x minus 4 would give us negative 2x, and then negative 2 times negative 4 gives us positive 8. Okay, if we have two binomials whereby there's nothing particular about them in that they don't look the same, they are not identical binomials, they're not similar binomials, then we just perform FOIL on them. So it means that we do the first, the outer, the inner, and the last. So the example here given is 2x minus 3 times x plus 5. So 2x times x gives me 2x squared. 2x times 5 will give us 10x. Negative 3 times x gives us negative 3x. And negative 3 times 5 gives us negative 15. We then collect our like terms, and collect the like terms means that we take our x terms, so here and here at 10x and negative 3x, we add them up together so that our final answer goes to 2x squared plus 7x minus 15. Our third form of the expansion is where we have the special cases or the shortcuts, which is the difference of squares. So the difference of squares has basically, it's got the same terms inside the two parentheses, except one of them has a positive in it and the other one has a negative. So it's either a plus and it has to be a plus or a minus and a plus. And instead of performing the entire FOIL process, then what you would be doing is you would just be squaring the first and squaring the last, because our middle x term, or our middle AB term in this case, disappears because it gets cancelled out. So 2x all squared gives us 4x squared, and negative 3 times positive 3 gives us negative 9. And there's our final answer. The last form is the perfect squares, and the perfect squares are where we have identical binomials. So it's either a plus b all squared, or it could be a minus b all squared, which would give us a squared minus 2ab plus b squared. Alright, so what we do is, in using the shortcut form for that, what we like to do is we say we're going to square the first term. So squaring the first term tells me that I have x squared. I square the last term, which is positive 3 times positive 3, which is 9, positive 9. I multiply together the two terms inside the parentheses. Positive 3 times x is positive 3x, and then I double it, or I multiply it by 2, which goes to positive 6x. And there's our final answer. If we want, let's do the last example here. So the last example, again, it's a perfect square. We have identical binomials. So I square the first. 2x times 2x is 4x squared. I square the last. 4 times 4 is 16. Then I say 2x times 4 gives me 8x, but then I double it, or I multiply it by 2, so it goes to plus 16x. And so our final answer is 4x squared plus 16x plus 16. Now, this takes us to the next section that we're doing. And this next section tells us, well, what if we have, rather than having two binomials, what if we're multiplying now a binomial with a trinomial? Or what if we were multiplying two trinomials? What would happen? Well, what would occur there is we would just perform the FOIL process. Now, the FOIL process really just means that every term in the first parentheses is going to get multiplied by every term in the second parentheses. So you would continue and just say a times c, in this case, plus a times d, plus a times e, and it would be plus, now moving on to the second term in the first parentheses, b times c, plus b times d, and then b times e, plus b times e. And that would That would be our final answer. Now, of course, there can be situations here where there is going to be the collection of like terms, and therefore you would add or subtract as needed. All right, so let's just do a couple of examples. So if I do x times x squared, that'll give me x cubed. Then x times 2x will give me 2x squared. X times 3 will give me 3x. 4 times x squared gives me 4x squared. 4 times 2x gives me 8x. And then 4 times 3 gives us 12. Okay, so given this now, I can bring together the like terms. So I've got an x squared and an x squared there, and I've got an x and I've got an x there. So I can collect those like terms and say x cubed plus 2x squared plus 4x squared plus 3x plus 8x, and then plus 12, so that the final answer turns out to be x cubed plus 6x squared plus 11x plus 12. So I've multiplied every term in the first by every term in the second bracket. Again, we'll do one more example where we've got x times 2x squared, which gives us 2x cubed, and then x times negative 5x gives us negative 5x squared, and x times 6 is going to be plus 6x. We then have plus 4x squared minus 10x minus 10x for the next one, and then it'll be plus 12. So we collect our like terms where possible. So we have an x squared and an x squared, and we have an x and an x, so that I collect those like terms, and we have 2x cubed minus 5x squared plus 4x squared plus 6x minus 10x, and then plus 12. So that we have 2x cubed, 2x cubed minus 1x squared minus 4x, and then plus 12. And that's our final answer. That pretty much covers what we do in this last section of the chapter. So your work to be completed in class or to do as homework, we'll see, is exercise 3G, all of it, and I'll also be asking you to do the review sets. All right, see you next time.